All right, so second half of a lecture on habitat modeling is specifically talking about models that involve climate. So another term for this is bioclimatic envelope models. These are also called species distribution models, sometimes just climate envelope models, lots of different terms out there for this type of approach. But essentially, the idea is we're trying to understand the climate conditions spatially where a species can exist. So, if we're talking about this butterfly, for example, we can hopefully, from one or multiple different sources, get some information about where the butterfly has been observed. So, in this case, a bunch of different locations across the upper Midwest of the U.S. And then we can compare these locations of where the species has been observed to climate conditions that exist across that region, wherever it is that we're looking. And we might say, all right, well, this butterfly, maybe we know something about the butterfly related to climate, and we know that, it has limitations in terms of its heat tolerance because something related to its physiology. And so we might hypothesize, for example, that temperature might be a limiting factor, and maybe specifically springtime temperature when the larvae are turning into butterflies, right? And so we could use those climate conditions to specifically, kind of hone in on the climate conditions that we think are relevant for whatever our species of choice is. So before we can get started on this type of thing, we need two things. First, we need some distribution data. So we need to find a place to get all of these dots on the map, right? And the second thing that we need are climate conditions. In the list of data sources that's posted on Moodle, there are various links in there, and one of the links is for WorldClim. So this, which are basically interpolations, spatial projections of climate conditions, over kind of an average, I think 30-year period from 1970 to 2000. So that's where this particular map of precipitation across the lower 48 came from. But you can, I think, pretty easily download gridded raster data of climate conditions for precipitation, temperature, whatever it is that interests you. Another good data source is PRISM, which is out of Oregon State University, and that is more focused on the lower 48, whereas WorldClim is for the entire world. Both of those data sets tend to be kind of slow to download, especially if you're trying to download a large area. So just bear in mind that you might have to give it a little time to download those data. All right, the other question though I do want to walk you through a little bit, which is where do these point distributions come from? So here are some really good resources for distribution data. One is gbif.org. So these are museum records that have been digitized. Many of them are spatial. Some of them just give you information about like the continent or the state or the county, but many of them will have a latitude, longitude associated with them as well. So for example, if you wanted to work on that butterfly or any general species on Earth, plant, animal, whatever, gbif.org would be a good place to look to see if there are spatial data records for that species. Another good source, although this is specific for invasive species, is EDMAPS, which is the Early Detection and Distribution Mapping System, which is run out of the University of Georgia. I work a lot on invasive species, so I find this a really useful resource for understanding and finding distribution data for invasives. And then another source of distribution data are researchers. So, other people in the world have colored animals or observed animals. And so we have some examples of, for example, the bears in Newfoundland or the mountain lions in Southern California, project ideas for that. So I'm going to do a walkthrough right now, but there is also a walkthrough of doing these types of bioclimatic models, the bioclimatic envelope model, in week 12 of Moodle. This is called the tutorial is called Simple Habitat Suitability, and I can show that to you. It's basically right here, Simple Climatic Suitability Tutorial in week 12. All right, so where we want to get started is I'm going to walk through basically, a lot of what's in this tutorial using EdMaps data. So if you are wanting to do this final project with modeling plant invasion risks, then this should really help you get started. So the first thing is to go to EdMaps, so edmaps.org, and look for the species that you are interested in. So I'm going to type in kudzu because that is the one in the example. So that's Prairie, Montana. And we should then be able to go to, this is some information about the species itself, but what we're interested in are the point distributions of these. So you saw a little thing that popped up there that they have over 8,000 records for this particular species. To get to the point where you can download those data, you're going to need to create a login. So I don't think I've ever gotten an email from EdMaps. They're just trying to keep track of their users. So create an account on this website. Once you log in, you will be able to click this button, which is to download the CSV. So that is a comma separated value format. So something that you can open pretty easily in any spreadsheet, including Excel. So when I click on this, it'll tell me, okay, how do you want these data? I want everything. And then it'll say, I'm going to send you an email with instructions. So for me, the email arrived within like a couple of minutes, and then I've got this link to go ahead and download the CSV file. So let's open that up. And here's what the file looks like. Basically, in Excel, Excel is able to read in that CSV just fine. And there's a lot of information about who collected it, when it was actually observed, when they entered the date, blah, blah, blah. There's a whole bunch of stuff over here, like that it was located north of the Chick-fil-A parking lot. Lots of important information if you wanted to get into these data. All that we care about are these two pieces of information, the latitude and the longitude. We don't care about any of the other things because all we want to do is get those dots on the map. And so what I'm going to do is just delete everything else, delete these rows at the top, and I will just remember that it's WGS84 is my datum, and get rid of everything else. And I'm going to insert one other row, which is just to remind myself of what the species is, that this is all kudzu. And we'll see if it lets me drag it down to the bottom. Any gaps and stuff, Excel will basically stop at, so I'll fix that in a second. Then I'm just going to filter these so that they all sort in the same manner, because basically what I want to do is to get rid of any blanks at the end, right? I don't need any of these data where there's like nothing here, right? So I'm just going to delete all of these excess rows. And then when I go back to the top, I should be able to enter kudzu and get it all the way. I messed myself up because I entered it before. So when you do this, enter kudzu at the end, then you won't have to scroll all the way down with all of these stupid things. We've got lots of latitudes and longitudes in here of things that look generally familiar, right? Like 35, 34, north latitude, and negative, 80, 70, something like that. West longitude, all of those look pretty reasonable. So now I'm just going to do a save as for this thing. Download seems like a good place to save it. I'm going to keep it in the CSV format because I know that GIS and Excel don't always get along super well. All right, so let's see if we can find my downloads folder. downloads, and I'm just gonna connect to that folder so that I can open it up and hopefully find Kidzu in here someplace along with a whole bunch of other crud that I need to delete. All right, so off we go, bringing Kudzu in here. First thing I always do, open this guy up, right? Make sure that there's something in here. Okay, good. Looks like we've got Kudzu, we've got latitude and longitude. This is bringing us back to lab 5, right? So I've got longitude in the X field, latitude in the Y field. Need to make sure that I define a coordinate system here. I know, because I was just looking at it, that we've got latitude and longitude, and that the datum was WGS 84. So I'm going to enter all of those. And then we can see a bunch of dots on a map, and you can kind of see the extents of the US kind of popping up here. So all of that looks good. I'm going to do my data export data and save this as a shapefile along with some other stuff I've been doing. I don't know why I keep adding a Y to Kudzu. There we go. All right, so now I've got my pictures here on a map as an actual shapefile. So I'm going to get rid of those other things because those were just temporary files. Let's see if I can find my other folder. Okay, so I gave you a couple of example spatial data layers, annual precipitation and January minimum temperature. Those are both available in that tutorial zip file. So I'm just going to evidently very slowly add those in right now. Thank you, GIS. And my minimum temperature. Okay, so here's my raster grid. Here's my point distribution on top of it. And basically what we're trying to do is understand what are the climate conditions that underlie all of these points, right? So this is going either back to or forward to lab 7, where you need to do some extraction of the values in the raster into the point data sets. There's some other stuff going on here too, in that there are some data points in Hawaii and some that are, I don't know where that is, off in the Atlantic Ocean someplace, presumably that's in an island. If you just want to kind of limit it to the stuff that's in the lower 48, you know, like I would say an easy way to do this is to select those and do a data export data again as, call this Kudzu in the lower 48. And I got rid of a couple to deal with. Okay, so lab 7, if you recall, had a feature that is called extract multi-values to points. I'm too lazy to type that all in, so I'll just go with extract multi because I know that that will pop the thing up. Come on. And this gives us this option of getting all of the raster information into our point data set. So here's our point data set, right? And I want to include both annual precip and January T-min. And I'm just going to rename this. I'm going to get rid of the average so that I can remember that this is T-min and not T-max or T-mean or something like that. Okay, so if we set that off, then basically what we're going to find when we get to the end of this is that next to our, we can see the little lock turns on, so that indicates that it's ideally doing something right now. We can check our results, see that yes, indeed, it is working on this particular thing right now. And what we'll see when this finishes is 2 new columns in our Kudzu from the lower 48 that include the information of January average T-min and annual precipitation. Okay, so now that finished, that took a minute or so on my computer. I'm going to open the attribute table and see that, yes, indeed, I now have 2 new columns that are January minimum temperature and annual precipitation. Now, one thing that's kind of important now is to get some intuition as to what these numbers actually mean, right? So you should always either look in the lab or look in the metadata or go back to the website where you downloaded these layers to figure out what is 132 in terms of temperature, right? So it turns out that temperature in this particular data set is represented as degrees C times 10. So the January minimum temperature at this particular location is on average 13.2 degrees C. So nice warm location, warmer than Massachusetts. And I believe that annual precipitation is in millimeters. So this would be 147.6 centimeters on average of annual precipitation. All right, so we've got some data. Now we want to analyze it a little bit, at least. So one way we can do that is back in Excel, right? So GIS, not that great for plotting XY data, but Excel is pretty good at this. So that means that we need to export this table as a table that Excel can read. And I like text. Excel cannot deal with info tables or D-based tables, so text is definitely the way to go. So here's my kudzu table, and I don't want to add it, not interested in any of that. I'm only interested in my ability to find that in Excel. All right, so here's Excel. Thanks. I'm going to do a Control O to open a new thing and browse for that. In my downloads, I think is where I know, I guess I saved it to temp, right? All right, so here's a tricky part, which is that Excel looks for all Excel files. A text file is not an Excel file. So we want to, lots of fun things in here. Kudzu text file, I think, is the one. Oh, look at all the things that I have called kudzu in here. Kudzu table.txt. That's better. All right. Oops, that was the wrong one. Thanks, Excel. Kudzu too. This is a much better way to read it. All right, so this one is the one that's actually the text document, is what we want, not the XML. I don't even know what XML is. Open the text document. And here's a piece. Now Excel is asking you, well, how do I put these values into columns? And so you have to look at this and you can see, okay, there's a comma that's separating the different columns, right? So you have to tell Excel, okay, it's a comma, separate them based on that. And then I will get my data set into Excel in these different columns. Okay, so now one of the cool things that we can do is to insert a chart. I want to do a scatter plot. And nope, that's not what I want, Excel. Thank you very much. I guess it's easier if we just select the two first. And insert, and I can see actually there's some problems with my data here, and then I have some negative 9999s, which are probably not going to be super helpful in here. In fact, let's clean that up before we go any further. Oops. Just going to filter these so that I can see things, and I'm going to just select the negative 999s and get rid of those. See if there's any. Oops. See if there's any others. Okay, I don't see any of those in the precipitation, so I think we're okay. All right, so back to, Excel always tries to figure out what it is that you want, and usually it doesn't do that at the first go. So if you select the things that you actually want to plot, then sometimes that helps Excel a little bit. Okay, so now I've got this scatter plot where Excel has added a helpful title, which is not all that helpful. But basically what I've got is my x-axis is temperature, right? Because I can see there are negative numbers in here, and you can go below 0 degrees C in temperature. And then my y-axis is precipitation. And there are ways in Excel, right, to like tell it where to put the, I don't even know. You have to explore a little bit to figure out how to tell it where to put the axis edge. Vertical crosses at, so I can change this to -150, put that, it's annoying when it's right in the middle of your data. All right, and then we could add titles to these, right? We could call this January minimum temperature and annual average precipitation. But generally the thing to look at is, okay, we have these, you know, kind of interesting blob of data here, basically. And then we have some like, you know, little bits and pieces out here on the edges, right? So if we were going to define, you know, like habitat or like the best possible habitat conditions for kudzu, we might, you know, one of the simplest things we could do is basically like define it by drawing a rectangle around the bulk of these data, right? So let's do that for argument's sake. Let's say that we choose a minimum of 1,000 and a maximum of 2,000 in terms of precipitation, and a minimum of -100 and a maximum of 50 in terms of temperature. I'm writing these down so that I don't forget them, 1,000 to 2,000. So we're looking at the data, we're saying what are some reasonable conditions, and then we're going back to GIS to see what those conditions look like on a map. So back to our lab 6 stuff. Master calculator, where we can say, all right, I want January minimum temperature to be greater than -100, and my January minimum temperature to be less than 50. Default geodatabase, so Jan kudzu. Actually, kudzu tmin seems like a better choice in terms of what we can name that. And then we get, you know, what we would expect, a true false layer, where here are all the places where we had between those two temperature ranges sort of suitable for where the bulk, and you know, this overlaps with the bulk of where the kudzu is, so that's comforting, right? So there's our minimum temperature, and then we can do the same thing for our precipitation. So annual precipitation less than or equal to 2,000, and our annual precipitation greater than or equal to 1,000. And let's call this kudzu precip. And off that goes. All right, and that also looks like a 1-0 grid of climate conditions. Great, so if we wanted to combine these two things, then that is just simply saying this and this, or that times that would also work. So we can call this kudzu precip tmin. And we end up with a grid that is, all right, here are all the conditions, and you notice this actually includes Massachusetts, where based on current climate for kudzu, where we might expect this particular species to be able to establish. And then if you wanted to do this, you know, you can add a climate change piece to this. You could say, all right, well, you know, if I have a future climate grid, I can apply these same conditions to those future climate grids and see where kudzu is likely to go, or whatever the species is that you're working on is likely to go. The other thing though that I want to like kind of touch base on is that this rectangle that we just defined as like, circumscribing the bulk of the data also includes some spaces like up here where there are no data, right? Or over here. So this may be because these climate conditions simply don't exist in North America, and so there's no way that the species could get there. But it may also be because the species has some correlations between precipitation and temperature, right? So for example, as it gets warmer for a plant species, it might need to also get wetter, because if it gets too hot, then that species is going to need more water. Otherwise, it's likely to wilt. It transpires a lot more water, and so you tend to have these kind of correlations between climate conditions. If it's cooler, might need less water, might be able to survive in drier places, basically. And so as a result of that, recognizing that there are these sort of correlations between data fields, people who work on species distribution models, on bioclimatic envelope models, also have created more sort of like higher level ways of dealing with that information. So we know that there tends to be some correlation, like plants wilt under hot temperatures. And because our sort of like base level GIS, that walkthrough that we just did, can't account for that, there exist several bioclimatic envelope model methods out there that can account for that correlation. So Maxent is probably the best and most commonly used example of a envelope model these days, but there are a whole bunch of these other ones out there too. So that's a synopsis of envelope models. The walkthrough of that tutorial for climatic suitability is in week 12. If you'd like to work on a invasive species or a native species, you now know EdMaps and GBIF, places that you can download data, and WorldClim or Prism, places that you can download climate data. So feel free to explore those for final project ideas.